Well, I've just had to do the white balance on the overhead camera because this looked distinctively greeny yellow. Anyway, looks at monitor, that looks the right colour now. The Midland Ready Rescue, we did one a couple of years back. But, you know, last year we did several of these, and we did a field test where Mr. Chippy went out in the car using one of these with its aerial which is supplied. So whereas we do the on-the-air test here using our base station aerial, and they're all done the same, whether it's a mobile or a walkie-talkie or one of these, when it came to the field test, it used its own aerial, and we had some good results. I think the most outstanding one was the Maxcom 7E, and I'd never had a Maxcom 7E before. I'd never seen a Maxcom 7E before, but I ended up buying about 3 or 4 of them just to get one complete kit, and that had that little advantage of having a removable carrying case with a battery pack in it, so you could actually use it as a walkie-talkie. The Cybernet ZX1 seemed to have the least efficient aerial, but was still a good product when used on a different aerial. And then we did the realistic one, which you'd expect to work well, and no doubt did. I can't remember. We have got some others. We've got the Cobra one, and we've got the Harvard 3-channel one. So I'm going to make sure we've done all those this year. So this one, I don't know, I've got a soft spot for these emergency kits. I probably never had an Action Man as a kid, and so I ended up again having to buy 3 different kits to get one complete setup, and it's always the aerial that's missing, and this aerial looks to be in okay condition. Oh, it comes with an aerial adapter. They've obviously used it with something else, and a magnetic mic clip which can go in the bin, and a telescopic aerial, of course, which is the important thing. And on this, I hope that's intact. Yeah, that's it. And on this model, like with the Maxcom, and of course it comes out of the same factory, you have an aerial that will screw in to the top, so you can use it as a hand portable, kind of, but tethered to the car's cigarette lighter connector. So you can stand out of the car whilst your car's on the hard shoulder waiting for the AA, other motoring organisations available. You can at least stand a few feet back and still talk on your radio. Of course, you could have a battery pack, couldn't you? So it's quite versatile. And one of the things I like, which some people would not like, is it doesn't have an LED display, so it's not drawing current. So this draws less current, so it's better on the battery. This one's April 1982. So we'll come back to the kit part of that later on. I'll be checking that for continuity and all that behind the scenes. So it's actually the radio, of course, that we'll be servicing today, and then we'll do an on-the-air test as we usually do. I've got one of these coming in for service from an end user, actually, and I was hoping it would have come before we did this, because then I would have serviced his on the video instead of servicing mine. So better open it up. Now we've got a circuit diagram, because when we had these originally, I had the sense to photocopy the instruction book, which had a circuit in the Maxon fashion, and I've done these before, but we've got that, so that I'll be able to fill that in a bit, which will help. It shouldn't be too complex, because it's quite a basic set, and not having a meter is something else that doesn't have to be adjusted. I think it's pulled the knobs off. I'll select channel 20 first. To be honest, I'll probably put these through the dishwasher. There, I've done it. Yeah. metal pillars help with the, you know, you can end up with these things with broken mounting pillars and all that. So you've got an electric condenser mic, you've got a speaker, which I tell you what, that speaker is bigger than most mobile sets are today. And this hasn't been touched. I can't see any screwdrivering, so I mean this should be fine. Can't see any capacitors grinning at me. I don't think it's been overvolted. I think a lot of these, you know, they might have been bought new at the time in 81, 82, 83, especially in the clearance sales when things like this were going for $14.99 at Dixon's, and after Plustronics went bust, and you end up people's, oh, it might come in useful, and it ends up in a cupboard, and it ends up in a cupboard, and it still ends up in a cupboard, and then these people pass away, and relatives either get a big skip and throw everything out, or they do chuck a few things onto eBay. I don't think there's much. I think I paid $37.50 for this one. You know, they aren't being given away anymore. But they would have been in the £49 to £69 region when they were new. So what we need to do, I'll recover that power lead, because we may as well run it on its own power lead. So I've got 3 bodies, but no accessories. We need our adapter. Now, as you know, we need to connect the test instruments up to the loudspeaker, and at least you can get to it to put a crocodile clip on. This doesn't feel that tight, which isn't very useful. You'll notice between the antenna socket and the screw-in receptacle for the aerial when you mount it on the body of the unit, there is a loading coil. So the loading coil must be in the antenna base for the magnetic one. Okay, so I better see how many volts this is. I don't know whether it's 12 or 13.8. If it's 12 volts, it says on the specification, so we'll do the servicing at, I think it'd be fair to do it at, tell you what, we'll do 12.4, because a fully charged battery is going to be 12.8, so that would be a not very full battery. So remembering which switch is which, we'll switch it on. Oh yeah, and plug it in. And there we have about 2 watts of audio. More potent than you expect. So I'll put picture in picture and then we can look at where the transmit is. So I'll press transmit and let's hope that antenna connector is not too loose. Yep, so there we go. So we've got about 2.8 watts. It's about like doing a brand new set out of the box. Now the circuit diagram, the scan of the photocopy is so poor that I can't see what is what. So I'm expecting, oh, it does say that's VC. I've got this upside down. They want you to have it that way on. So it's transmit, 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 transmit. That's not shown as being variable. And the VCO is there. Right, I'll put the soldering iron on in case we've got some wax to melt, and we will start off. I'll just zoom in a bit. I think we can on this one. So going into transmit. Just how many watts is it supposed to be? 4. Let's go back one because they're interactive. Takes us over the 3. So it's actually doing a good 3 watts. If we look at the fine scale there, press transmit, it's well over the 3 watt end stop. So it's probably about 3.1, 3.2. To be honest, in all seriousness, on a par with a lot of brand new mobile sets. We will put this on the Zetagi meter to see what fictitious watts it does. So we know that we've got TX, 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 TX. So our receive ones and the IF ones are going to be those ones. So I'm expecting those two to be front end and those two to be IF. And one of those will be detector. I say the circuit diagram is so dodgy. I don't think I can read the values. No. Is L9 one of them? T9? No, it's one of those two anyway. So let's look at deviation. This will be fun because I've got to have to whistle into that mic or put the tone generator into that mic. Wallow, wallow, wallow. It's actually spot on, 2.2 to 2.5. So we don't need to even get the oscillator out. So that makes a change. Now we've got 2 presets, RV2 and RV1. One of those would have been deviation. Oh, I haven't checked whether it's on frequency or not. just see whether we can just read enough of this circuit. I know it's going to end up, we're going to be trying to adjust the squelch, which would be what one of the presets is, and end up changing the deviation and having to go back on that. Anyway, that's my prediction. So that's how it's doing on frequency. So it should be 27.79125. Oh, look at that. 27.79127. That's something else I don't need to adjust, but it's the trimmer, the red trimmer down there. If I was to adjust that. Wait, this is an easy peasy one. It really was working. I've actually bought something off eBay that works. So I'd be tempted to think that the preset down here which is RV2, I'd be tempted to think that's going to be a deviation, and I therefore would suggest that the one there is going to be squelch, and that's because it's nearer to the MC3357 chip, and that's nearer to the phase lock loop. That's my logic. So unless we have to go back on the deviation, then we'll go over to receive. Okay, so on receive, let's put the oscilloscope on. And we'll need to connect that to the test instruments, hopefully with only one wire, because it should be picking up its earth through the aerial. So we'll just go on the inner to the speaker. Yep, that seems to be right. It's an S9 signal on the signal generator, which is 100 microvolts. And we'll adjust whatever we expect to be the detector. So it's either going to be that one or that one. It's that one. I'll tell you what, that was a bit out. And that IF one sounded like it was a bit out as well. In view of that, I'll do the IF one next, using the cyanide meter. Just go back now on the... No, that stayed put. So now we'll look at the sensitivity, which isn't that brilliant. If I tell you right now that it's doing... Wow, it's doing 1 microvolt for 12 decibels. So we'll set that to about there. See if we can tune the front end any better. Wrong tool. The answer is yes, we can. Knock that down. And once again check that IF1. There we are, tuned. So we'll look at the cyanide now. So we'll say it's doing 3.2 watts. Cyanide is 20 dB, 12 dB and 10 dB for those three readings. And at the moment our 12 dB one is now 0.79. Our 10 dB one .75, and our 20 dB one, if the radio will achieve that, it will. Surprise, is 1.7. It's 12.1 that's important, and that's fair enough. Let's see where the squelch is. Now normally I like to be able to squelch out S9, so I'll just put the camera onto the attenuator controls. That's 30 microvolts. I'd like to be able to squelch that out. I can. So let's see if it opens at 100 microvolts. No, it doesn't. I want it to. So with that preset, yeah, I was right, it's squelch. I want it to open. Now when I turn the signal generator down to 30 microvolts, I want it to go away. It doesn't. It's got a bit greater hysteresis than I would expect. Now it needs to come in at 100. I think that's the best compromise. It's got quite a wide range, which is fair enough as an emergency set. But I don't want it so strong that it never squelches out anything. So we'll now, I'll take that clip off, we're done. We'll now look at the sensitivity at the other end of the squelch range. So I'll switch the signal generator off. So we'll set the squelch to threshold. Switch the signal generator on. See when it comes in. It comes in at 1.4 microvolts and it leaves at 0.55 microvolts, so it's got a very wide range. And of course you can always turn the squelch down when you're calling for help on a distant signal, can't you? So we're done. There's nothing more to it. I didn't have to touch deviation, and deviation is going to be that one there. So we'll just fill in a bit more of this. So we know that was deviation. We know that's the VCO. Oops, nearly did the wrong one. We know that's the squelch. We know these are the front end. We know that's the detector. And we know that's the IF. So finally, back to that one, which is going to be the VCO. there's no reason to do anything to look at that because it's never been fiddled with. There we are. Done it. That was an easy one. Didn't say it was going to be easy to put back together though. Screws have got a bit of corrosion. Probably been in the damp boot of somebody's car. Then before we leave it, we'll just check the power. Now it's had a chance to cool down a little bit. Remember, I'm running this at 12.4. I don't want to run it at 13.8. And it might be at that point, it might try and do 4 watts. Tell you what, we're going to do that. It is a 12 volt radio. I don't want to destroy it, but at least it's mine and not a customer's. There we go. So right now from cold, we'll go back to camera 1. I was going to say don't try this at home, it's a 12 volt radio. Yeah, so it's doing 3 watts. Let's turn up the power supply to 13.8. And at 13.8 volts, it's doing 3.6 watts. So back to 12.4. We're just doing over 3 watts, about 3.2. So I'm going to put the knobs through the dishwasher, I may as well, and I might put the whip or something like that through. But what we will do is very temporarily we'll put that knob back on, so we can just have a flick round. Switch off the test gear. Oh, I know what we'll do before we do that. We'll put it in the Zetagi meter. So we are doing about 3.2 watts on the Marconi meter. It's doing exactly 4 watts on the Zetagi meter. Perhaps Midland set them up with Zetagi meters. Okay, so we'll plug that in. One nano, Roger. It reassuringly says that 19 is highway channel. It doesn't say it's burner and clown channel, does it? I'm sure it's not just where I am. Well, I say where I am. I'm 35 miles from the nearest city, but that's what we pick up. Right, well, we'll do a test with this later on with Mr. Chippy from here, and then we'll subsequently, probably tomorrow, do a field test with it as the mobile on its own aerial. So I like these, they interest me, and thank you for watching the Midland Ready Rescue 77810 from 1982.